keep spreading awareness. As far as the subject is concerned, there are two experts, so I would rather like to leave it to them to engage in discussions and um, inform you all about the subject. But there are two, three things which I would like to highlight or stress amongst the students as we were discussing, before the event started. I would wish that, all such events, and not only these events, many more of such events be taught by the students of the society, under the umbrella of society or without the society. You should organize, you should think, you should have the creativity of, doing one thing or the other in this field. On the day, without a particular day, it doesn't matter. But the activity matters, and there should be a variety of activity, and these are possible. You would probably be knowing that, there is a startup which has successfully made a rocket and sent. So why not you? The next rocket should come from you. If not rocket, then the satellite should come. If the satellite doesn't come, doesn't matter. You find out an application which solves some problem of the community. So there are immense possibilities, and you can do a wonder. You only have to have the, वो कहते हैं कि पेट में आग होनी चाहिए. अगर आपके पेट में आग होगी, तो आप definitely कुछ ना कुछ अच्छा कर पाएंगे. And the objective of all of us collectively is to make this world better. I end with these words. I have lots of hope from the young generation, Gen Z, or the young this generation. I'm sure they will do well, and I look forward to having more such events organized by the society and by the students. Thank you all. Welcome once again, everyone. And over to you, Rupika.
Thank you so much, sir, for your valuable words and for setting the context for the today's event. So, friends, before we move on to our main section, we are fortunate to have among us Dr. B.K. Badra, former remote sensing scientist at ISRO and currently professor at Delhi Technological University. With his extensive experience in remote sensing and space applications, he has made valuable contribution to India's Earth observation and satellite research over the years. On this special occasion of the National Space Day, we would be honored to hear his thoughts and insights. Sir, may I request you to kindly address the gathering? Over to you, sir.
Thank you very much. It is a nice initiative, I think, by Professor Theory, and who has invited a eminent scholar, Dr. Sanjay Jain from NIH Roorkee. Just I like to highlight some of these very key features, the success of this Chandrayaan 3. I walked both this Chandrayaan data sets as well as your Mangalyaan data sets. Both the data sets I've used for different applications. So maybe just I will see you some technological or strategic point of view when you are going to land. That means from that your orbiter, from the satellite to the land. Just 5-10 minutes, just I would like to mention. Now this is challenge. Now as you know that we have launched this Chandrayaan 1 and Chandrayaan 2 as an orbiter. Initially the Chandrayaan 1 is in the orbiter, but second Chandrayaan 2 in which we have a lander provision as well as a rover. But this causes some fatality. That means this could not able to set. Orbiter was the successful. It is that means you are collecting acquiring the data of this on entire moon surface. But during landing there was some difficulties. Now I will tell you that what are those difficulties which faced in Chandrayaan 2 and how this has been overcome in Chandrayaan 3. And as you know, this in Chandrayaan 3, which has successfully this lander which is set foot on the moon surface on 23rd August 2023, just 3 years back. So those few points just I want to highlight. What are these points? As you know that, let us suppose you are at some particular altitudes of 300 kilometer, 400 kilometer as the orbiter. Then from there to landing on a particular place. Now, before that, what you have to do? You have to identify the site suitability of the landing site. That should be smooth, plain. It should not be too hard. It should not be too soft. It should be plain areas, not too rugged topography. So that was that one initially in Chandrayaan 2, there was a limited area that 500 meter by 500 meter only they have selected. They thought that it will be landed. But there was some problems in that during landing. What was that problem? There was mainly four problems was there during this landing. It was that there was a software glitch. That means software could not able to communicate properly. That was during landing. Then there was what happened suddenly there was some because of the thrust of the different engines in that your lander, whatever there is a speed, it suddenly increases and they could not able to tolerate that. Then speed was generally it is maybe at around 30 kilometer altitudes. The speed was 1.6 kilometer 1.6 kilometer per second. Now this has to be brought down to only 0.5 meter per second speed when it landed on the moon surface. That was a very difficulty how you can control it, control the speed and those. But there was a thruster, definitely that engine which is fired, the 5 engines will be fired, but the speed was slightly very high. As a result, what happened? There is a hard crash. It happened. And of course, during this when it is about to touch the surface, what will happen that legs and the arms of this your lander, including the rover, which got crashed. So there was some unsuccessful things. Therefore, I can give you the software glitch, then high thrust of these different engines, then small area because they have selected initially because you do not know because that area, as you know that this Chandrayaan 3, that area have been selected in the southern pole. And there was a very crucial period, as you know, that in the Mars, in the moon surface, there are 14 days daytime and 14 days nighttime. Now, only that 14 days daytime, you have to reach that your landing and then you have to collect the data. When the night temperature goes to minus 400 degrees Celsius. Therefore, we have to, that certain corridor, this has to be done. So there was a lot of this, some problems was there, which have been overcome in Chandrayaan 3. And it was actually by AI techniques, this entire, these simulations have been done and this could able to succeed this entire this from that lander is touch the feet very precisely, and then rover has that means come out from this lander and it collected the that means on the it roamed around 100 meter distance on moon surface and they have collected a lot of data sets. So that was some difficulties. Therefore, just I like to just summarize that failure leads to success. Sometimes what will happen in any endeavor, any type of whether you're doing job or anything else, that if there is a failure, we should not be disheartened. Then this failure, if you can overcome, you can analyze those failures, then you can succeed your endeavor. Therefore, Dr. Abdul Kalam, he says that you should have a great aim, then acquire the knowledge of difficulties and do hard work, and definitely there will be success will come in future. So with this a few words, just I'd like to conclude that Chandrayaan 3 was very successful in 2023, and Government of India, they have been encouraging to all the youth, all the youngsters, they should come forward and take in this space technology as a future career. Thank you very much to all.
Thank you, sir, for those insightful words and for sharing your valuable perspective with us today. And now, as we move forward towards the main session of today's celebration, it is our privilege to have with us Dr. Sanjay K Jain, retired scientist, National Institute of Hydrology, Roorkee, and faculty at IIT Roorkee. Dr. Sanjay K Jain is a retired scientist from the Water Resources Division of the National Institute of Hydrology, Roorkee, where he served from 1988 until his retirement. A civil engineer by training, he holds a BE from MNR Engineering College, Allahabad, now NIT Allahabad, and MSc in Hydrology from the National University of Ireland, and a PhD from the University of Roorkee, now IIT Roorkee. With 3 years of research experience, Dr. Jain specializes in remote sensing and GIS applications in hydrology, snow glacier hydrology, GLOBE, that is glacier lake outburst flood, and studies and reservoir sedimentation. His work has been published extensively in leading international journals such as Natural Hazards, the Journal of Earth Science System, and the Journal of Mountain Science. Over his career, Dr. Jain authored 51 international and 13 national journal papers, 28 international and 43 national conference papers, and 38 technical reports as well. He served as PI or co-PI on more than 38 sponsored and consultancy projects, organized 18 training programs and workshops, delivered over 175 lectures, and guided 26 postgraduate and 8 PhD students. He is a fellow of the Indian Association of Hydrologists, the Indian Society of Remote Sensing, the Institute of Engineers, and the Indian Water Resources Society, member of the International Association of Hydrological Sciences. He was honored with the Best Scientist Award of NIH in 2000. Dr. Jain brings with him valuable experience and expertise, and we are truly grateful to him for joining us on the national occasion of Space Science Day. National Space Day, and taking the time to share his knowledge and perspective with us. Sessions like these provide students with an opportunity to learn directly from experienced professionals, gain new perspectives, and understand the possibilities that lie ahead in the field of science, technology, and space related applications. We are certain today that in today's interaction will be an enriching experience for everyone joining us. So without further delay, I would like to invite Dr. Sanjay Kumar Jain to take over the session and share his insights with us. Dr. Jain, sir, the platform is yours.
Okay, thank you, Rupika, and good morning to all. Congratulations on this occasion of National Space Day. Thanks to Professor Tiwari for giving me this opportunity to be with you on this particular day. So now I'll share my presentation and then we will discuss some of the things. Okay, can you see the PowerPoint?
Yes, sir.
Okay, so if you see that geospatial and space technology, which we are using in most of our studies and different projects, they are powerful tool for understanding our Earth, managing resources, and solving real world problems. So we are using these two technologies. As you know that space technology uses satellite and spacecraft to collect information from space, and geospatial technology uses location-based data to analyze and represent information. All of you know that. And in India, if you are talking that we are having very strong capabilities, as something has been told by Dr. Bhadra also, in both the fields through ISRO. So using Earth observation satellites, communication satellites, navigation systems, geospatial applications. And when I joined NIH Roorkee in 1988, our first satellite was launched in that particular year. And since then, we are working in this particular area, and number of satellites have been launched by ISRO in the field of remote sensing with different capabilities, different resolutions, and also in future, like again told by Mr. Bhadra that Gaganyaan or Chandrayaan. So the capabilities and I can say specifications of the satellite have increased over the years, and we are getting very good data now, which we can use for different purpose. Already told by Ms. Rupika about the importance of this day. We have started in 2023 this year when Chandrayaan 3 mission successfully soft landed near moon South Pole. So we all of know this thing, and that's why we are celebrating this day on this 23rd August. So it is well known. Now, why we are using geospatial or space technology? If I am talking about the simple chain, satellite data collection, image or data processing, then GIS analysis, and then map information and decision making that we are doing through this. For example, during a flood, satellite observes flooded area, images are processed, then GIS image. I will show you some of the slides also, like we have done some floodplain zoning with the help of space technology and geospatial technique. And space technology provides the eye from the above, while geospatial technology converts that information into useful maps. So that's why we are using this technology, or in broad term, if you see, we are using for different purposes like decision making and planning. That helps in urban planning, disaster management, resource allocation, etc. Environmental monitoring, track changes in landscapes, forests, glaciers, water bodies over time, etc. And now, as you know, with climate change, we are facing a lot of glacier retreat and glacial lake outburst flood. So, in that field, we have used this technology very much. Then, infrastructure development, disaster management. So, in different fields, that's why we are using this geospatial and space technology in different areas. How it works? Already, all of you are familiar. You are working in the particular field. Remote sensing, GIS, GPS, geospatial analysis. In geospatial analysis also I have seen, though I have not worked in this particular area of AI, machine learning, big data analytics, etc. So this is the advancement of the geospatial analysis. So we have different technologies which forms our geospatial and space technology. So here you can see, and we have to use means for data we are using like Earth observation systems, and GIS we are using for our analysis part. So again, I'll repeat that simple change: data collection, data processing, analysis and visualization, and decision making. Okay, so this is our chain which I've already explained. If I am talking about the space observations over the year, as I have told you that in 1988, India launched its first satellite IRS-1A. At that time, if you remember, the resolution was 72 meter or 36 meter. And now we have come up to 1 meter or less than 1 meter. So higher resolution, larger swath, low resolution data, medium temporal resolution, large swath, that is coarse spatial resolution. So this is the global to local we can say. So we are having very means high resolution data which can provide us a detailed information about that area, and we can visualize the a very small feature also on the earth. So this is the journey we can say global to local. If I'm talking about the applications, as you can see here in different areas, agricultural and soil, forest and environment, water, I will speak mostly on water or cryosphere, then disaster support, weather and climate, land use, land cover or land related, ocean related. So these are the different applications of these technologies. So natural water resources management applications, water resources assessment, in which there are so many areas where we can apply this two technology: land use planning, soil erosion potential evaluation, watershed planning, vegetation mapping, ecosystem analysis, cons- conservation planning, risk assessment, coastal zone management, etc. So there are a number of areas where we can apply this technology. So if I am talking particularly for water resources, so here we can see that water occurrence varies spatially and temporally through the hydrological cycle. And also, as you know that we are having topographically the low-lying area or coastal area and Himalayan area. In Himalayan area, we have used these technology in different studies. So there the topography varies very fast. Now we can have that through our digital elevation. So this technology helps us in number of ways for Himalayan region. So we can have water resources assessment and management. Various combinations of geographic information systems and simulation models can be effectively used. In hydrology or water resources, we are using number of mathematical models. Maybe you know that. In those models now we require number of inputs. So we can have them from space technology. And to handle those inputs or the field-based inputs, we can have GIS. So there, using both these technologies, the simulation model we can apply effectively. I'll show you some of the examples. In order to optimally utilize land sparse water resources, data information is needed on parameters such as rainfall, availability of water, surface water, groundwater, land use, land cover, elevation. So all of them, land surface temperature, thermal data if we are having, then we can have the temperature information, which is very much useful in our evaporation or snow cover, snow melting. So all of that information which was not available that much effectively, now we can have using these technologies. So the applications in water resources, if I'm talking, and I'll cover some of them, that is flood mapping and management. It is one of the major area now, because in India now you can see that we are having a plan or a initiative in floodplain zoning, snow glacier melt runoff and modeling, hydrological modeling, irrigation water management, drought monitoring. So these are the areas of applications in water resources. I'll cover some of them. The inputs from satellite data, maybe all of you know the process which I have just shown here. Statement of problem, data acquisition. Earlier like from NRSA we were getting that data, but now online data, number of data are available, image processing softwares are available. So all of them we are having, only thing we have to download the data and then we start working. So we have to do some kind of processing and then we can have the inputs from satellite data. Just it is in brief flow chart how we can get. If I'm talking about the water resources inputs, we can get even the rainfall, ET, surface water, snow glacier, soil slopes, land use. Water means whatever inputs are required to carry out any study, that is possible now through space technology. All the inputs required for any study, even the rainfall, even now some of the studies you can find there we can have the discharge information from satellite. So you can see that most of the inputs now are available through this space technology. Only thing we have to apply them effectively in our different models or techniques. So in brief, I can say that hydrological model mostly we are using for any particular water resources problem. So there RS, GIS and DA. These are three technologies we are using extensively, and then we are combining all of them in hydrological model to solve any problem. Here you can see, first I'll talk about the flood management, because it is now in almost every river. Now floodplain zoning have been taken up by government. So some of the studies we are also carrying out in Bundelkhand region. So there we are using the space technology and the model to solve, to delineate the risk zone map or floodplain zone maps. Here you see the floodplain. If you understand, these are the floodplain areas corresponding to certain magnitude of flood. Like if we want to draw a line of 10-year return flood or 100-year return flood, we can draw. The aim of this type of study is to delineate the area where we can restrict the development so that we can avoid the damage caused by the flood. Here we are using both the technology. So like here, if we have to use, or the flood modeling models we have to use, this is the flow diagram of this. We have to have the software like HMS or HECRAS. Maybe some of you are knowing. These are the free online software which we are using in this particular type of studies. And we have to have the ArcGIS or any GIS package. From there we can generate different layers, and then we have to perform the modeling. This is called as the hydraulic modeling, mainly, where we have to delineate the flood inundation area. So how we can do that? Just here, if you see the different input parameters I have just listed out here, the cross sections also we can have from DM, then lateral and elevation coordinates, left and right bank station locations, etc. etc. So these are the inputs, and if we are taking all of them and applying into a model, then we can draw a flooding areas. But sometimes we have to verify. How we can verify? Using space technology. Here if you see the satellite data, so on the left side it is before the event which occurred in 2013 in that particular river of Haridwar area, and on the right side you can see a image which shows you the post flooding. So here if you see on the left side in yellow line, it is within mostly the river boundary, while in the right side it is in the downstream area, some of the area got flooded. So whatever we have done, we can verify or we can check or even we can validate through this type of space technology, and then we can draw finally the flood affected area. So in the downstream area, you can see that particularly on the right side, a lot of area is under floods. So that area we have to demarcate in the field so that people cannot have any developmental work in that particular area. Okay, so this is one of the application of modeling and space technology. Now coming to the other part, that is snow cover mapping and modeling, because as you know that in our three major rivers, that is Ganga, Indus and Brahmaputra, they are originated from the Himalaya. And snow and glacier melt contribution is one of the major contribution at a particular location, especially in the higher altitude. So if we have to do that modeling, we require snow and glacier cover. How we can get? Through only the satellite data. So if you see here, the snow and cloud, they are the, it is difficult to differentiate. On the left side, if you see a false color composite of three bands, and now if we have replaced that by short wave infrared band, then we can differentiate between snow and cloud. So there are techniques, there are the advancement of satellite data, there are advancement of the techniques through which we can delineate snow and glacier cover area accurately. So that is the first requirement. We have to know how much is the snow cover area, how much is the glacier, how they are changing with the time. So how that snow will be converted into water, that through modeling we can do them. So first target is to know the snow cover area. Like here in using NOVA also. NOVA is of course a very coarse resolution data, but for a large basin we can use that and we can see how that snow cover changes over the different months. So like you can see here in July and August, as you know that snow cover is at minimum. So the variation of the snow cover area, we require to model to get how much contribution from melting we will get during evolution period. Similarly, using MODIS data, they are the coarse resolution data. Similarly, if you have to have the glacier characteristics, as you know that we have a snout, that is the last point of a glacier that we can have from satellite data. If there is a lake at the snout, then that can be dangerous. So that is a glacial lake. So we can see also how that glacial lake varies over the years through satellite data. So here you can see the different features, and using different years of satellite data, we can delineate the glacier area. As you can see in different areas that we can demarcate on the satellite data. So here if you see the glacier change in one of the basin we have studied in Satluj and in Ganga. So here if you see that in 1990 or 2020, how much is the change? So in Ganga river we have found that glacier cover have reduced by almost 4%, while in one of the tributary of Satluj you can see 20% glaciers have lost over the years. So they have impact on the water which we are getting from the glacier cover. But our first aim is to see the change in the glacier cover. Here if you see in different areas, in different years, how that glacier is changing. In the last figure I have shown with the purple color mainly, the area which have been vacated by the glacier. So you can see that a lot of area which were earlier covered by glacier, we have delineated those areas, and then we can see the impact of this particular change, because that is very much required for different purpose, mainly for hydropower generation and for other purpose. We are getting this water in the downstream area. Okay, but our first uh, way is to have all these information from satellite data. Okay, so that we can have using different techniques, and DSI and even now machine learning languages or ANN have been applied. So these are the advancement of the technique which we can apply to get the change in this glacier cover area. And also one of the model which we are extensively using is SPHY model, through which also we can get the snow cover area. So here we have compared the snow cover areas using Moody's satellite data as well as using SPHY model in BASPA. And we have found that they are matching not exactly but very well. So this is one of the model which can also give us the snow cover area. Suppose we are not having snow cover area for some of the time due to some regions, then we can get that information from the model also. So here then SPHY model, which is very much used in snow and glacier melt runoff modeling, we have used number of models starting from our own model, snow model, then WIC model, then even SWAT model, and now SPHY model. The advantage of this particular model, it can give us the contribution of glacier melt. So some of the models are giving only snow and glacier melt runoff combined. So here, if you see in Upper Ganga Basin, we are getting like up to Rishikesh 14% of the glacier melt. So what we did, we have taken all that inputs from remote sensing as well as DEM, and then we have applied that into a model. So if we have to solve any problem in our water resources, we have to use mostly the space technology, spatial technology, and the modeling. So these three, if we combine, then we can get the desired outcome. So here, if you see the contribution of snow and glacier and rainfall and waste flow through that model, we can get in a particular basin at a particular location. Similarly, here in Baspa Basin, so here if you see that about 70% of the snow and glacier melt contribution. There are a number of projects in this particular region, hydropower projects, which depends on this snow and glacier. So how they are changing with the change of glacier cover, which we are getting from space technology, we can say that, and in future also, with the climate modeling, we can get, say, in 2050, how much will be the contribution of these snow and glacier melt. So that is very much useful for the hydropower companies, because they have to depend on this particular contribution mainly in the lean period. Once there is a monsoon, we are getting sufficient water, but like April, May, and June, we have to see how much water we are getting from them. That is possible through all that combination or integration of these technologies. Similarly, you know that we are again facing in Himalayan region a problem of glacial lake outburst flood. If you remember, in 2013 Kedarnath flood, and in 23 South Lunag, which is a lake in Sikkim Himalaya, that failed, and because of that, lot of damage occurred in the downstream area. So in the recent past, we have done number of studies or projects in which we have used this technology to solve or to get the desired output in that particular areas. Glacial lake outburst flood is nothing but if in case a lake which is under vulnerable category fails, then it will create a sudden release of water or flash flood, and that in the downstream area will be a very damaging. Like we have seen in Kedarnath, you can see in the picture. Recently in 23, we have seen one of the project of NHPC, Tista project, got damaged because of that flood, because it is coming in a very short period. So those projects actually require the amount of flood that is possible in case any lake located in that particular basin fails. So that information through this technique we have to provide. So here you can see how a lake is changing with the time, or sometimes a new lake is forming. So over the year, you can see one of the lake which is in Bhutan Himalaya. We have done one study in Bhutan Himalaya for NHPC. There we have seen that this lake have increased 3 times over the years. So one day it may fail because it is increasing over the years. So this is a dangerous lake. So we have to first demarcate these type of lakes using satellite data, and then we have to see the changes in the area, and then we have to go for a model in which we are using the inputs which we are getting, say, from DA. So I mean to say we have to have all these information or data from different sources, different satellites, and then we have to utilize for them in a model. Because ultimately, through modeling approach, most of the time, we have to get the desired output. So here you can see this is in Janskar region. We have done one study and we have seen two lakes which are in a vulnerable category and how they are changing. So the only source is the space technology through which we can get how much area of that lake is there and how this is changing. And then we have to identify the dangerous lakes. Once we have demarcated all the lakes, rising lake water level, activity of supraglacial lake position, means all that information we have to have with us through this technology, like condition of associated mother glacier, how that lake is fed by the major glacier, and how it is changing over the years. So we have all that data. We have to generate all that output from this data, and then we have to see how much vulnerable is that lake. So all that the criteria of vulnerability, which is given by CWC, we have to get from this technology. Okay. So once we have found out a lake, just I am showing you here how we are getting the output through a model. Like if you see a lake is there and that fails, then how that water will move in the downstream direction and how much flood we are getting at a particular point. So like at a bridge, at a settlement, how much is the magnitude of flood? If we know that, then we can, or if you know the flood affected or flood inundated area, the damage is because we are not, the people or proper, this infrastructure is there in the vicinity of that river and we are not taking care of that. If we know how much area will be inundated in case that lake fails, or how much magnitude will come at a particular site, then we can design our project accordingly, or we can take the different measures so that we can reduce the damage. We cannot avoid this type of natural disaster, but the losses which are occurring because of these events, that we can minimize. Okay, so that is our purpose of getting all that information through these technologies. So another application, if you see, is the reservoir sedimentation. We have carried out number of studies and using space technology in different months, how that reservoir is changing. We have to extract that water body from that satellite data, and then we have to again apply some kind of different say simple empirical models, etc., so that we can know how much sediment is coming to that reservoir, or how much sediment is depositing in that, and what is the sedimentation rate. So there are number of areas, I mean to say, in particularly in water resources area or water resources or flood, this hydrology, where we can have that number of inputs, and then some kind of modeling approaches we can apply, some kind of advanced techniques we can apply, like maybe some of you are applying machine learning or ANN or other techniques. These are the advancement. It is not a simple classification like earlier we were using supervised or unsupervised, but now for better classification, the data is the resolution of data have improved as well as the techniques have improved. So we are getting good information now using this advancement. So here you can see, and using this we can then estimate the sedimentation rate, which we are carrying out in the field. So the advantage of this technology or advancement of this technology is we have to minimize our field work. We need not to go to the reservoir and then we have to carry out hydrographic survey and all that. Means we have to do some kind of ground truthing or some kind of field observation, but that we can reduce. Some of the time we can means have a input from the satellite data, needing not to go to the field. So that is the advantage. So like you see here how that in the month of October, just after monsoon and just after onset of next monsoon, how much that area of that reservoir, this is a Bhakra reservoir on Satluj river, how they are changing. So that we can generate. So just to conclude, then we have some discussion also. So geospatial or space technologies are vital for understanding and addressing spatial challenges. And as I have said, its integration with emerging technologies like AI, IoT, and cloud computing further enhances its potential, making it indispensable in data-driven world. The data banks should provide digitized maps and their spatial data compatible with various systems. This is also very much required. We need not to do some of the work which already have been carried out. India Varis, maybe you have heard, Water Resources Information System. So there we are having some of the maps. We need not to repeat that. So if we are having data banks where we have this type of data readily available that can be utilized for our different purpose, we have to only take that data from that source and then we have to apply that in our model. We need not to do all that exercise of developing that data again. Geospatial and space technology are dispensable for addressing global changes such as climate change. Like glacial lake outburst flood, nowadays mainly is because of the global warming or more melting or more change retreat of the glacier. So like climate change, disaster management, urbanization, you see a lot of urbanization, resource scarcity. So by enabling precise spatial analysis and real-time monitoring, it empowers governments, business and communities to make sustainable and informed decisions. So we are getting better information in a very short period. That is the advantage. Proper image processing of remotely sensed data, DM and spatial temporal analysis with GIS would be very effective for water resources assessment and management. When we started working in floodplain management, we faced the problem of high resolution data. But for some of the area, 1 meter resolution DM have been developed. They are very much useful for flood related issues. Some of the studies we can carry out by a coarse resolution DEM of say ASTER or SRTM or ELAS, etc. But like in flood studies, we require high resolution, which is now not available online, but for some of the area or particularly in Ganga area, they have been developed. Maybe one day they will be available online. So that is again advancement of this. LiDAR technology have been used. Survey of India have carried out this survey and LiDAR technology they have used and is providing us the high resolution DA. So these two technologies can assist in developing management scenarios. We can see the different management scenario, provide options to policymakers for handling water resources related problem in most efficient manner. That is there. We were doing this water resources modeling, etc., without remote sensing and GIS also earlier. But with the help of these technology, we are getting better input, better output, etc. So this is one of the advantage. And recent developments of decision support system. There also we are using this integration of GIS and water resources model. So decision support system also is based only on these spatial and space technology. So this is in brief, I have just covered here the application and these two technologies. So now I conclude this talk and we can have some of the questions or queries if you have. Thank you.
So any questions, anyone? Neha?
No, sir, not right now.
Okay.
So can I ask something?
Yeah, please go ahead.
So, sir, you were talking about like how the water from the glacier comes like downstream, right? And you told like we can find about the magnitude of flood at a certain point. So, I wanted to ask you like how will we find out about the magnitude of flood? Like how will we analyze the magnitude of flood at a certain area?
Jain sir.
Sir, you are muted. Jain, sir, you are
Sorry. Yes. I could not hear properly because my speaker maybe they are not good enough. So can you repeat the question?
Yes, sir. Sir, you were talking about like how the water from a glacier comes downstream, right? And you told us like you can find out about the magnitude of flood at certain places downstream. So I wanted to ask like how will we find out like the magnitude of flood at certain area? Like how do we know that,
The downstream area?
sir?
No, like if you are asking regarding that Himalayan region or
Sir, regarding Himalayan region,
uh,
Himalayan regions, regarding Himalayan regions.
no, you are talking about the downstream area, how we can get or
Yes. A downstream area, calculation of magnitude and speed, etc. How do you find out downstream when a lake has burst or something has happened? So when the water flooding happens downstream, so speed and other things, magnitude, वगैरह, वो कैसे calculate करना है? That is what she wanted.
Okay. If you know anything about the modeling, particularly now we are using HECRAS model, and in that model we can compute a flood magnitude at any point. Either it is because of the Gulf or it is because of any flood in plain area. So at any point, if you want to compute the flood magnitude, we can get the velocity, etc., and water level as well as the flood magnitude through that model. Because in that model, we are having the total length of that particular river from the source to the last point, wherever we are, means whatever stretch we have taken. So through that model, we can get the magnitude. We cannot get from this directly from remote sensing, but we have to use the model. Aditi wants to know something. Yes, please.
So,
Yes.
sir, my question, like you have mentioned a model regarding the glacial, I think that glacial outburst flood. So, I want to ask that how does that SPHY account for changing glacial extent under climate change? And how does this dynamic glacier change affect the modeled contribution of this glacier melt to the downstream runoff?
Okay, there are two things I can understand. One is the glacier change and the impact of that on runoff. Other is glacier change or retreat and the impact of that on the lake.
Yes,
So,
sir.
okay, so if I'm talking about the glacier retreat, which is directly feeding to that particular lake. So, as I've said that we have to get the inventory of the glacial lakes first, and then we have to identify the lakes which may be vulnerable. Already NDMA, CWC, NRSC, they have identified almost 188 lakes in the Himalayan region. So we have to do that exercise and we have to see the glacier which is feeding to that particular lake. So the glacier retreat we can have from the remote sensing and we can say that this particular lake is getting more water because of the retreat of the glacier. So directly, if we are doing glove modeling, we need not to have that anything on the glacier melt runoff. We have to do the lake modeling. If we have to see the glacier change, then there are a number of models. As I have said, we have used SPHY. It is a open source model. We have to get the different inputs and then we have to see like in 2000, how much was the glacier cover in 2010, 2020, 2025. And those glacier maps, we have to give input in that particular model. And then we can say that this much of the glaciers have reduced over the years and that what is the impact of that glacier change on the runoff. Okay, so whatever magnitude or this value of runoff we are getting with the input of that glacier map which was there in that particular year, we can say that the change is say 20% and then runoff how much is there. So we have found that in some of the, if I'm talking about the watershed which are having large volume of glacier, we are getting more water because more melting, more water. But in some of the watersheds, the glacier cover have reduced up to some that extent that we are not getting sufficient water. So in those watersheds with the glacier melt, we are getting less water. Okay. So we have to have the glacier cover maps and correspondingly the runoff with the help of that model. Is that okay?
Okay, sir. Thank you, sir.
Okay.
So I have a question. Uh, so
Yes.
in context of Assam, how can we predict the inundation or how can we create a flood early warning system in Assam? Like this year,
In
it has been a havoc.
in
In
Assam.
Assam, yes, sir.
Assam.
So what
Yeah.
would be your perspective that how can we provide the
Yeah,
solution
it
to
is
the
very
problem of
difficult
Assam?
as you know, it is very difficult, I can say, because as you know that Brahmaputra is not a river, it is a, like a means very large river, or we can say the span of or the area of that river is very large. We have not done any study in that particular river. So, but I can say that like we are doing number of studies in Bundelkhand region or some tributaries of Ganga River, but in Assam I have not even seen any study. But it will be difficult because you know the water spread area of Brahmaputra is very large. Okay, but we can do some kind of HECRAS modeling there also, taking a stretch of that particular river, but we have to know the flood at a entry starting point and how much area it will inundate in the downstream, then we can have. So far we have not done, but I can say that it will not be as easy as in that other rivers, but we can do using HECRAS modeling.
Okay, sir. Thank you, sir.
All those interested in learning more about water and water related modeling, you all can request him. We can organize a 1 or 2 days workshop,
Yeah, yeah,
and we can invite him so that you get to have a better understanding.
yeah.
Uh,
So
so the
far, more than 10 river we have in the recent past we have done. So we can show you some case study also from the starting, and using how we are creating input, how we are getting the flood magnitude, how we are then using HECRAS, etc. So as said by Professor Tiwari, we can organize 2 days or 3 days, whatever.
right. So the Geospatial Society people, just think of 2-3 days when you want it. So you can give me an application. I'll make a note, get the approval, and we can organize it.
Okay, I'll I'll, I'll talk to
Right.
you on that aspect and then we can.
Yes, 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 yes. Okay, I think it's time that you conclude now. Neha, Rupal, and Anjita.
Rupika,
Thank you, sir.
Anjita.
Thank you so much, sir, for such an insightful and engaging section. Your valuable experience, perspective, and knowledge have certainly made today's celebration of the National Space Day more meaningful. I'm sure that everyone who joined us today has taken away something valuable from this interaction and has gained a fresh perspective on the field. So, on behalf of the AntriX, DGST, and the Delhi Technological University, I would like to express our heartfelt gratitude to Dr. Sanjay Kumar Jain sir for taking the time to be with us today and for sharing his valuable insights and experience with us. So, as we come towards the conclusion of the today's event, it is my privilege to deliver the vote of thanks. First and foremost, we would like to express our sincere gratitude to our Honorable Vice Chancellor and Chief Patron, Professor Pratik Sharma, for his patronage and continued support towards the student-led academic initiatives at the Delhi Technological University. His encouragements provide us with a platform and confidence to organize initiatives that bring students closer to knowledge, research, and emerging developments in their field. And I would also like to sincerely thank our respected KC sir for his valuable address, guidance, and continued encouragement towards the activities of the AntriX. And we would like to also express our sincere thanks to Dr. B.K. Badra sir, former scientist ISRO and Professor Delhi Technological University, for gracing the occasion with a special address and for sharing his valuable insights with us. And our heartfelt gratitude to our esteemed speaker, Dr. Sanjay Kumar Jain sir, retired scientist, NIH, and faculty at IIT Roorkee, for joining us today and for sharing his valuable knowledge, experience, and perspectives with all of us. Sir, your interaction with us has made today's National Space Day celebration truly enriching, and we are grateful for your time and effort that you have taken to be a part of this event. And I would also like to thank all the faculty members, students, and the participants who has joined us today. Your presence as well as the enthusiastic participations are what makes such initiatives meaningful. And finally, I would like to appreciate the entire AntriX team for their efforts in planning, coordinating, and successfully bringing today's event together. And as we celebrate the National Space Day, let us continue to remain curious, keep exploring, and contribute towards India's journey in science, technology, and space exploration. And thank you everyone for joining us today and making this celebration special. Once again, happy National Space Day. Have a wonderful day ahead. Jai Hind.
Okay, thank you everyone. Thank you, जैन साहब, बहुत बहुत धन्यवाद आपको.
Thank you, Professor Tiwari. Thank you.
Okay, bye bye.
Okay, bye. Thank you.